Hi guys, welcome back. In this video we are going to state and prove multinomial theorem. So firstly, in the statement we have to explain what is multinomial theorem. Multinomial theorem has the n number of positive terms. The positive terms are taken as x1, x2, x3, xt. We have this is the formula for multinomial theorem, that is x1 plus x2 plus xt, x3 plus xt is equal to summation of p, where is n ratio a1, a2, a3 and at, so on till at, and x1 to the power a1, x2 to the power a2, x3 to the power a3, where the summation extends over all the sets of non-negative integers, where these are the non-negative integers, that is where a1, a2, a3 so on till at is greater than or equal to n. There are c bracket n plus t minus 1 comma n terms and expansion of a1 plus x1 plus x2 plus x3 so on till xt to the power n. This is the statement. Now we have to prove the multinomial theorem. So prove the coefficient of x1 to the power a1, x2 to the power a2, x3 to the power a3, so on till xt to the power at is number of ways arranging the n number of terms. We are arranging this n number of terms as x1 dot a1, x2 dot a2, x3 dot a3, so on till xt dot at. Therefore it is p n ratio x1 a1 plus a2 plus a3 so on till a3 at. We have to write this same here step, and the number of terms is determined as follows. Each term of the form x1 to the power a1, x2 to the power a2, xt to the power at is selected is the selection of n objects with the repetitions from t. It repeats in repetition of t, distinct types. Hence, they are c. We write ncr ways. So we write here c n plus t minus 1 comma n ways. So hence we have proved the statement and proof of the multinomial theorem. If you like the video guys, like, share and subscribe. Thanks for watching. See you in the next video.